Hello guys, today we will solve some PYQ question from Machine Learning Foundation. It is asked in 2022 in May term. So let us start with the first question. The first question is for the data sets xi, yi. These are the data. These are the points from 1 to 5. Consider the regression model fx is equal to x plus 2, and we have to find what is the mean squared loss of fx. So let us see the solution of this question. The mean or average squared loss for regression model fx is given by 1 by 5 summation 1 to 5 y minus fxi a whole square. If in general it is 1 by n, it will be 1 by n, but we have 5 data points, so we will write here 5. So let us make a table x, y, fx and y minus fx ka whole square. So these are data points. We have write down the data points and calculated the fx, and then calculated the y minus fx ka whole square, and we have calculated, and the sum of all these y minus fx whole square, summation of these values are 10. So the loss for given model fx is 10 by 5, that is equal to 2. So 2 is our answer. Let us proceed with the next problem. The next problem is fx x1 x2 x3 is equal to x1 plus x2 plus x3 divided by 3 is used as an encoder function, and gu, u, 2u, 3u is used as decoder function for dimensionality reduction of following data set. So, and we have to give the reconstruction error for this encoder decoder pair. The reconstruction error is the mean of the square distance between the reconstructed input and input. So we have information from the given problem, and we have an encoder function f and decoder function g. This is a encoder function, this is a decoder function. So to address this problem, we will encode each data point, and using the encoder function to obtain fxi, and then decode it to get g of fx of I, and we will measure the squared error by computing modulus of g of fxi minus xi ka whole square. This process will be repeated for all data points, and the average error over all data points will be calculated to obtain the loss. So there are only 2 data points in the question, and this is from R3. This is points from R3 plane. So we have an input 1, 2, 3, and we first encode it using the function f. So what was our output from this encoder function? 1 plus 2 plus 3 divided by 3, because fxi given is x1 plus x2 plus x3 by 3. So that is equal to 2, and then we will decode it using our decoder function, that is g of u is equal to u, 2u, 3u. So we will write down 2 multiplied by 2, 3 multiplied by 2. So that is our points will be after decoding the function 2, 4, 6. Then we will calculate the squared error by computing this 2, 4, 6. Our output is this, or our input is this. Then we will subtract the output minus input, and then squared it. So for first data points, the squared error is 14. Then for second data, similarly for second data point, similarly we have calculated this, and this is our 35. So then we will to calculate the loss, we take average of these errors. So the loss will be 14 plus 35 by 2, that is 49 by 2 is equal to 24.5. So let us proceed with the next problem. Problem number 3. What will be the directional derivative of fx y z is equal to x square y cube minus 4xz at point 1, 1, 1 in the direction of -1, 2, 0. So So the solution of this problem is the directional derivative at the point is determined by taking the dot product of the gradient at that point with a unit vector indicating the direction in which the directional derivative is required. So we will first calculate the gradient of the given function. So the what is the gradient of the given function? And this is the gradient of the function del f by del x, del f by del y is equal to del f by del z. So we will calculate this 2x y cube minus 4z x square 3y square minus 0 0 minus 4x. So we have calculated this, and then we will calculate this gradient function at point 1 comma 1 comma 1, because we have to find direction derivative at point 1 comma 1 comma 1. So we will calculate this. So this is our result, minus 2 comma 3 comma minus 2 3 minus 4. So next what we have to do, we have to find the unit vector along minus 1 comma 2 comma 0, because this is given in the direction of minus 1 comma 2 comma 0. So we will find out the unit vector along this direction. So what is the unit vector along this direction? This calculated by the magnitude. We will divide the vector by its magnitude, and this we have found magnitude as under root 5, and then we will find the unit vector along this direction. And so finally we have calculated the directional derivative. So the directional derivative is given by del f gradient of the function at point 1 comma 1 comma 1 by and dot product with unit vector. So we have calculated this, and so we have calculated this, and the answer is 3.57. So let us proceed with the next problem number 4. So for what value of k will the following function will be continuous? So the function is given, and so what is the concept behind this to solve this problem? The concept is, for the function to be continuous, left hand limit must be equal to right hand limit. So we have calculated the left hand limit. So let us take graphical representation from there. Suppose this is a function, and we have to find out the left hand limit. So let us take this as a point x is equal to 2. So we will calculate for to check the function is continuous at this point x equal to 2. We will check right hand limit and left hand limit. So first we will check left hand limit. So left hand limit will be left hand side of this point. So this this point is denoted as 2 minus, and right hand of this point x equal to 2 is denoted as 2 plus. So we will calculate x limit x tending to 2 in left hand side. So the function at left hand side is at less than 2. So the what is function? 3x square minus kx plus 5. So we will write it down, 3x square minus kx plus 5. So we will substitute the value of x and find 17 minus 2k. Similarly, for right hand limit, we will substitute the function at 2 plus. So what is the function at 2 plus? So if the x value is greater than 2, 2 plus, then the function is 1 minus 3x. So we will substitute the value of function 1 minus 3x, and we will get the value of the function. We will get limit of the function at point x equal to 2, that is minus 5. Then we will equate these both the right hand limit and left hand limit. 17 minus 2k is equal to minus 5, and we will get the value of k as 11. So our final answer is 11. So let us proceed with the next problem. Problem number 5. Find the linear approximation of L of fx 2x1 square plus 4x to the power 4 around 1, 1, and use it to compute a linear approximation at point 1, 1, 1.1. What will the value of this? So we will find out we have to find out the value of this equation. So to find the linear approximation of of fx around the point 1 comma 1, we first need to find the gradient of function at 1 comma 1. So the gradient of function is given by this del f del f del f by del x1 del f by del x2. So computing the partial derivatives, 4x1 and del f by del x2 is equal to 16x2 की power cube. So now we will evaluate these derivatives at 1 comma 1. So we will get 4 and 16. So the gradient of function f at 1 comma 1 is 4 comma 16. So the linear approximation L around 1 comma 1 is given by this equation 1 comma 1 plus del f 1 comma 1 with dot product x1 minus 1 comma x2 minus 1. This can be rewritten as del f 1 comma 1 dot product with x1 minus 1 x2 minus 1. So we will compute this. So now plug in 1.1 comma 1.1 into L to find this expression, and we will calculate the value of linear function at point 1 comma 1 comma 1.1. So our answer is 8. Now we need to compute the value of function at this point. So the value of function at this point is 8.2764, and we have to find the value of this expression. So we will subtract it to 8.2764 minus 8. So the final answer is 0.2764. This is our final answer. Now let us proceed with the next problem. Problem number 6. The eigenvalues of the matrix are A, B, C in increasing order. Then the value of A plus B is. So the increasing order, so A should be less than B and B should be less than C. This is increasing order. These are the eigenvalues. Okay. So to find out the eigenvalues, we will first calculate the characteristic equation A minus lambda A is equal to 0. So we have calculated this 1 minus lambda, and we will diagonalize A minus lambda I. So 1 minus lambda, and 0 minus lambda, and 1 minus lambda. All the remaining elements will be as it is. So we will compute this and get the value of lambda as minus 1 comma 2. Since A, B, C are increasing order, so the value of A will be minus 1, B is equal to 1, and C is equal to 2. So we have to find out the A plus B. So minus 1 plus 1 is equal to 0. So our final answer is 0. Let us proceed with the next problem. Problem number 7. If A is equal to PD P inverse, where P is equal to this and D is equal to this, calculate A की power 4 and enter the summation of all the elements of A की power 4. Given that A is equal to PDP inverse, so to calculate A की power 4, we will use the given decomposition. A is equal to PDP inverse. We know that A की power 4 is equal to PDP inverse की power 4. So we have rewritten this equation as this. And however, P inverse P is equal to identity matrix, where I is the identity matrix. So we can simplify this. P inverse is equal to I. This P inverse is equal to I, identity matrix. P inverse P, and here we have mistakenly not written P. So we will this is also I. So we can simplify this. A की power 4 is equal to P D power 4 P inverse. So given that D is equal to minus 1 0 0 6, so only diagonal elements are there, remaining are 0. So D की power 4 is calculated as minus 1 की power 4 6 power 4. This is only valid for if diagonal elements are there. So we will directly compute this D की power 4 1 1 2 9 6. You can verify this. If we multiply D with D 4 times, we will get this. So now we will find PD की power 4 P inverse, and P is given as 1 1 2 1 minus 5, and D की power 4 we have calculated previously, and P inverse, so we have to find out the inverse of this matrix P. So to calculate the inverse, we have used this formula, adjoint of A upon determinant of P. So we will get this inverse as 5 by 7, 2 by 7, 1 by 7, minus 1 by 7. You can directly calculate the inverse of 2 cross 2 matrix. Take the determinant and interchange the diagonal elements, and take the minus sign of remaining elements, 2 comma minus 2 minus 1, and we have interchanged the diagonal elements. Minus 5 one is here and 1 is here, and we have take minus sign of remaining elements, and divided adjoint of 2 cross 2 matrix directly calculated. This is shortcut. You can verify this. And determinant of matrix P is 1 upon minus 5 minus 2. So we will directly return this and calculate the inverse of this matrix. And now we will multiply this 3 matrices. First we will multiply these two, and we will get this, and then we will multiply these two and get this. And so finally we have A power 4 is equal to 371 minus 370 minus 225 926. So the sum of all the elements of A power 4 is 371 minus 370 plus 926 minus 925. So our final answer is 2. So let us proceed with the next problem number 8. Find the values of alpha and beta for which the matrix A has eigenvalues equal to minus 1 and minus 3. Enter your answer as 2 alpha plus beta. So from the properties of eigenvalues of a matrix, product of eigenvalues is equal to determinant of matrix. So the product of eigenvalues is given as minus 1 and minus 3. So we will take the product of these values and equated with determinant of matrix. So determinant of matrix is 2 beta minus 2 alpha. So first equation is this, and we will use the second property of eigenvalues of matrix. Trace of matrix is sum of eigenvalues. So the trace of matrix is 2 plus beta, and trace of matrix is 2 plus beta, and sum of eigenvalues is minus 1 plus minus 3. So we have calculated the value of beta as minus 6, and substitute back this value of beta into equation first. We will get 2 alpha is equal to minus 15. So now we have to find out the 2 alpha plus beta. So we have substituted these values and get minus 20 as the answer. So let us proceed with the problem number 9. So the problem number 9 is identify which of the following scenarios necessitates the use of classification technique. So we have to find out which of these four are these four scenarios are example of classification technique. So the first is predicting the amount of rainfall in May 2022 in North India based on precipitation data of the year 2021. And the second is predicting the price of land based on its area and distance from the market. Third is predicting whether an email is spam or not. And fourth is predicting whether a patient has a cancer or not. So the solution is third, predicting whether an email is spam or not, and fourth is also to predicting whether a patient has a cancer or not. So these two options are correct. What is the reason? In this scenario, the task involves categorizing data into distinct classes, spam or not spam. So we have categorized these two categories, and in the case of cancer, we have categorized the patient, whether a patient is presence or absence of cancer. So we have two options, presence or absence of cancer, which aligns with the concept of classification in machine learning. So these two options are correct. These two are example of regression model. So okay, so let us proceed with the next problem, question number 10. Consider a function f(x), x minus mod x by x if x plus x equal to 0, and 2 if x equal to 0. Is f continuous? So we have to find is f continuous. So the for function to be continuous, what is the concept? Left hand limit is equal to right hand limit, and thus this must be equal to value of the function at that point. So we have calculated the right hand limit at 0 plus. At 0 plus, what will be at if at 0 plus, what will be the value of mod x? Mod value so the graph of mod x is this. So while calculating the right hand limit, it 0 plus, what will be 0 plus this 0 plus, and this is 0 minus. So this is a function y is equal to x, and this is the equation of y is equal to minus x. Okay, so the overall function is y is equal to mod x. If we and this line is belongs to y is equal to x, and this line belongs to y is equal to minus x. Okay, so at 0 plus, what will be the line? Y is equal to x. So we have in place of mod x, we have substituted x minus equal to 0, 0 by x. This implies the value of right hand limited 0. And similarly, we have calculated the left hand limit. So to calculate the left hand limit at 0 minus, what will be the value of mod x? Mod x will be minus x. So 2x by x equal to 2. So here we have seen that a right hand limit is 0 and left hand limit is 2. Since a right hand limit does not equal to left hand limit, the function is not continuous at equal to 0. Okay, these are answers. Let us proceed with the next problem. Problem number 11. For the matrix this, what is the dimension of its row space? So we will Gauss elimination method. We will use Gauss elimination method to convert this matrix into row echelon form. So we have converted this matrix by applying row operation R4 minus R2. This we have got this, and then we have converted this to R4 minus R3. So we have got this, and then finally we have multiplied second row by 2, and this substituted row 1. We will got this, and again we have applied these row operations, and we got this matrix. So the row space of S is span of its independent rows, non-zero rows. So the independent non-zero rows are this. So the span of row space of S is span of these 3 row. So in this case there are 3 non-zero rows in the row echelon form. Therefore the dimension of the row space of matrix is 3. So the final answer is 3. Let us proceed with the next problem. Problem number 12. Consider the system this, and under what condition on B1, B2, B3 is this system solvable? So to check this, to find out the condition, we will first convert this system into augmented matrix. So here matrix A is this, X is X1, X2, X3, B is B1, B2, B3. So the augmented matrix is this. We will apply the row operation and convert it to Gauss elimination method. We will use Gauss elimination method and get this. So the condition to be solvable, this must be equal to 0. So the B3 minus 2B1 is equal to 0. So our condition is B3 is equal to 2B1. So the answer is B3 is equal to 2B1. So let us proceed with the problem number 13. 13 is calculate the projection of vector this onto another vector. Which of the following the squared length of the projection vector? So calculate this. We will first count the projection matrix for A. So first we will find out the projection vector for this. So the projection matrix for A for vector this, for this vector, this is a transpose, so we will write it down this as A is equal to minus 131. Let we assume A is equal to minus 131. So to calculate the projection matrix, we will use this formula. This is in general formula to calculate the projection matrix. So we have calculated, first we have calculated A transpose, and this is a matrix A transpose, and then A transpose A. So so this will be the dot product of these two matrices, these two vectors. So the these two vectors dot product is 11. Now projection matrix P is written as this, because A transpose is 11 and A transpose is this matrix. So our projection matrix is this. So now we will calculate the projection vector. So to calculate the projection vector, we will project B onto A. To calculate projection of vector this B 2 minus 1 3 projection of, we will find out the projection of this vector. So we will write it down as B is equal to 2 minus 1 3 onto A. So PB is equal to this matrix multiplied by this matrix. So we will write it down as, we will multiply it, and this is a 3 cross 1 matrix, and this is 3 cross 1 matrix. So the final matrix will be 3 cross 1. So the PB is 2 by 11 minus 6 by 11 minus 2 by 11. So calculate the square length of the projection vector. 2 by 11 square minus 6 by 11 square minus 2 by 11 square. So the final answer is 0.3636. Okay. So let us proceed with the next problem. What is the problem? Consider the data set with input X and output Y is followed. So for the above given data set, Raj wants to compute a least square approximation that best fits the data set with minimum error. Which of the following is the correct for the best fit line? So we will use least square method to solve this problem, linear regression problem. So the for least square method, A transpose A X is equal to A transpose B. So first we have assumed that linear line, best fit line is y theta prime x plus theta double prime. So this is theta prime is slope and theta double prime is intercept. So first we have write it down using these 4 points. These 4 points are given. We have converted these equation. We have converted these equation 1 2 3 4, and we will write it down these equations into matrix form. So we will write it down in matrix form, and then here matrix A is x1 x2 x3 x4 1 1 1 1, and then we have calculated A transpose. Then we have multiplied A transpose multiplied by A. This is our A transpose A is equal to this, and then we have calculated the A transpose multiplied by B. Here B is this, our output y1 y2 y3 y4. Okay, so we multiply this. So our A transpose B is equal to 9 19 10. We know that A transpose A x cap is equal to A transpose B. So we have calculated these values. A transpose B is equal to this, and A transpose A is equal to this, and x cap is theta prime theta double prime. So we calculate this the value of theta prime and theta double prime. We have to find out the inverse of this matrix. So the inverse of this matrix is calculated by using adjoint method. Compute the determinant of this matrix, and that is 11, and then compute the inverse. So now theta prime theta double prime is written as multiplication of these two matrices. So we have performed the matrix multiplication and get the products. So the result of the multiplication is 6 by 11 17 by 11. So the value of theta prime is 6 by 11, and the value of theta double prime is 17 by 11. So we have substituted these values into our assumed equation, and that is the best fit line, and got this best fit line that best fit the given data points 0.54x plus 1.54x. So that's all the problems have been discussed in this session. Thank you so much. Please subscribe my YouTube channel for such PYK question series. Okay.